These are the lecture notes for Chapter 13 on the blood vessels. We are going to focus on, number one, learning the names of the arteries and the major arteries and veins of the body. And then number two is learning the differences between the arteries, veins, and capillaries. Okay, so that's mainly what we're going to focus on. Now, blood flows away from the heart through arteries. They branch into smaller arterioles. Arterioles branch into the smallest blood vessels called capillaries, and this is where the capillaries deliver nutrients and oxygen to the tissues and remove waste and carbon dioxide. So basically, capillaries are the site of gas exchange and the exchange of other chemical substances. The venules are smaller branches of veins. So they drain the capillaries, and then venules drain into the larger veins. And veins return blood to the heart. So arteries carry blood away from the heart. Okay? And then also this list also shows you starting with the highest pressure to the lowest pressure. Arteries are under the highest pressure of all the blood vessels, and then the arterioles, capillaries, venules, and veins. And I'm going to skip a lot of this information, but I do want to tell you, I do want to talk to you about how veins get blood back to the heart, because it's easy to understand how arteries deliver blood to the rest of the body, because the heart pumps the blood, through the arteries, and so they're under high pressure. So that blood pressure is the force, that transports the blood. But then when you get all the way down to the bottom of your feet, how is the blood going to get back up? It's under low pressure here. So how is it going to get back up all the way back to your heart? Well, there's a few ways. One is there's muscle activity. Skeletal muscles compressing against the veins will help pump the blood, back toward the heart. That's why we say that exercise increases our circulation. Also, once blood moves to a certain level, it won't go backwards through the veins, because veins have valves. Arteries don't have valves, but veins do. So valves will prevent blood from moving backward. And you can also get blood pooling in the veins, and that can lead to varicose veins. That's another thing that can happen with veins. But one other thing that we do that causes blood to move through the veins back to the heart is breathing. Breathing creates kind of a negative pressure. It sort of pulls or sucks the blood up toward the heart. Now, this is a good chart, overall chart, that gives you, the comparison and contrast between veins and arteries, venules and arterioles. But basically what you can see here is that veins have a very thin wall, especially a very thin muscular layer called the tunica media. And arteries have a thicker wall, but they have a smaller lumen, a smaller opening, whereas the veins have a larger opening. Veins will have a larger diameter, and arteries have a smaller diameter because of the fact that the veins are under less pressure, arteries are under greater pressure, so the arteries need that thick muscular layer. And really, when you get to the venules, there's no tunica media, there's no muscular layer at all, and the arterioles still do have some smooth muscle. Capillaries only are composed of endothelial cells and a basement membrane, so it's really just simple squamous epithelial tissue that forms what we call the endothelium. It's just a single layer of cells that form capillaries because they're very, very small. Why are valves found in veins but not arteries? And that is because the pressure that blood flows through arteries is great enough, it's not going to go backwards. But in veins, since the blood pressure is so low, the valves will prevent blood from moving backward through the veins and keep it moving toward the heart. Okay, again, we have these terms, systole and diastole. So blood pressure fluctuates, and the highest peak pressure is measured as the systolic pressure, and it's measured during ventricular contraction, or systole. And the lowest pressure in the arteries is measured as diastolic pressure, and it's measured at the end of ventricular relaxation, or ventricular diastole. We record it with the systolic pressure over the diastolic pressure. So here's an example. A good average healthy blood pressure is 120/80. We measure blood pressure with a sphygmomanometer, blood pressure cuff, and the artery that we use is the brachial artery. So I don't know where that is in the notes, but we learned that we take blood from the median cubital vein in a procedure called venipuncture. And so I also want you to know that the brachial artery that's a C. The brachial, B-R-A-C-H-I-A-L, the brachial artery in the upper arm is the one that's closed off by the blood pressure cuff. And so that is the one that when you release the pressure in the blood pressure cuff, the pressure through that brachial artery is what we're measuring. This is a graph showing you the pressures starting with the aorta, which is our major artery, and then into the branches of the aorta, down all the way to the arterioles, how the blood pressure kind of rises a little bit and then it starts going down. So the arteries have the highest pressure, and then the arterioles, and then the capillaries, venules, and veins. And the lowest pressure is actually in the vena cava. And we'll just skip this too. Okay, in a healthy person, where is blood pressure greater? At the aorta or at the inferior vena cava? And of course, it would be greater at the aorta. While standing in the hot sun, Sally begins to feel lightheaded and then faints. Explain what happened. She had a sudden drop in blood pressure. So let's take this question in two parts. First, let's start with the fact that Sally's been standing. She's been standing. We're going to assume she's been standing for a while. So what's happening to the blood in the veins of her lower body, especially blood is going to be pooling in her lower extremities, like her feet and her lower legs, because of the standing, because of the effects of gravity. Okay, she's not moving around, so her muscles aren't helping to pump the blood through her veins back to her heart. So blood is pooling. So not as much blood is being returned to the heart. That means the venous return is what that's called. The venous return is less. So if there's less blood being returned to the heart, that causes the cardiac output to be less. So her heart, the cardiac output of her heart is going to be less. And so that's going to cause her blood pressure to drop. The other thing is she's standing in the hot sun. Okay, so standing in the hot sun, she gets dehydrated, and that lowers her blood volume, because part of the volume of blood is in the plasma, is that water, that 92% water. So lower blood volume also means lower blood pressure. And so in both of those ways, her blood pressure is going to drop, and that's going to cause her to feel lightheaded and possibly faint. All right, tissue perfusion, or blood flow, is affected by cardiac output, peripheral resistance, that's the resistance of blood flowing through the blood vessels, and blood pressure. So these factors have to be regulated so that we get enough blood flowing to the tissues to deliver nutrients and oxygen to the tissues. Let's see what else. I'm skipping a lot of stuff. So regulation, by hormones in the short term, epinephrine and norepinephrine, which are produced by the adrenal medulla, the adrenal glands, stimulate cardiac output and vasoconstriction. They constrict the blood vessels and cause the heart to have a greater cardiac output, either by increasing contractility and stroke volume or increasing heart rate. Okay, that's the short-term regulation of to increase heart rate. For the long term, we have some hormones that can play a role. Antidiuretic hormone, or ADH, in fact, it's also known as vasopressin, causes us to, I can't think, I'm sorry. It causes us to conserve water. It causes our bodies to hold on to water, and causes the volume of urine to be less, and we retain fluid, basically. We also have a hormone called angiotensin II, and I can't highlight the 2, just it irritates me, but I can do it this way. But when I try to do it when I'm editing, that 2 is a symbol that it won't allow me to put the highlighter over. It's a little bit of a frustration for me. But these are hormones that help regulate the blood flow through our blood vessels. ADH, angiotensin II, EPO, because that's going to cause the production of red blood cells, which will increase the volume of blood, which will increase the blood pressure. So all of these hormones, ADH, angiotensin II, EPO, raise the blood pressure when it's too low. But then we have one hormone that's actually produced by the heart itself that lowers blood pressure when it's too high. ADH is released from the posterior pituitary gland in response to a decrease in blood volume, and it causes us to basically retain fluid, and that will increase blood volume, which will increase blood pressure. Okay, so that's how it works. And so it's released in response to lower blood volume, increase in osmotic concentration of the plasma. So that means the plasma becomes more concentrated, which would happen if your blood volume was less, if it's due to less, low water. And then also it's released in response to angiotensin II. So let's talk about angiotensin II. When blood pressure decreases or drops, the kidney secretes a substance called renin, and renin converts angiotensinogen into angiotensin II. So it's the renin-angiotensin system, it's what it's called. So what does angiotensin II do? Well, one thing we know it does, because we just learned this, is that it stimulates the release of ADH and also another hormone called aldosterone. Both of these are going to lead to an increase in blood volume, which will increase blood pressure. Angiotensin II also stimulates cardiac output and arteriolar constriction, and that's going to increase blood pressure. Stimulates the thirst center, so we drink more, so we have more water coming in, and that increased water is going to increase our blood volume, which increases blood pressure. Okay. So angiotensin II has a variety of ways that it acts, and it acts in conjunction with ADH sometimes, and another hormone called aldosterone, which causes our blood to retain sodium, and that water will follow the sodium. So it will cause our blood vessels to absorb sodium and then water, which is going to raise our blood volume, which raises blood pressure. Then we have EPO, erythropoietin, released by the kidney when blood pressure drops or when plasma oxygen levels drop. And it stimulates the production of red blood cells again, and what happens is that increases the blood volume and the blood pressure, and it also improves the oxygen carrying capacity of the blood. ANP is the one that's opposite of all these other hormones we just went over. It's atrial natriuretic peptide. It's released by the atrial walls when blood pressure increases. So the purpose of it is to lower blood pressure. So it will increase sodium loss by the kidneys, and water always follows sodium. Water follows salt. Water follows salt. Wherever sodium goes, water goes. So if you lose sodium through your kidneys, you're also going to lose water through your kidneys. You're going to have a larger volume of urine. It's going to reduce your thirst. So again, that will keep your blood volume low. Blocks the release of all these other hormones that we know are going to act opposite of ANP. So it blocks the release of ADH, aldosterone, epinephrine, and norepinephrine. And instead of constricting arterioles, it dilates arterioles, which is going to have a vasodilation will have a lowering effect on blood pressure, and vasoconstriction will raise blood pressure. So ANP, the final result is that it lowers blood volume and therefore blood pressure. Describe the actions of vasodilators and vasoconstrictors. So a vasodilator is some kind of chemical that causes blood vessels to dilate, and that will lead to lowering of blood pressure. Vasoconstrictors will raise blood pressure. What effect would vasoconstriction of the renal artery have on blood pressure and blood volume? I like this question because it forces us to, if you haven't noticed already, there's a strong connection between the kidneys, because the renal artery is the artery that supplies the kidney. So there's a strong connection between kidney function and our circulatory system and blood pressure. Excuse me. So if you constrict the renal artery, which is providing blood to the kidney, you're going to decrease kidney function, and it's going to lower the blood pressure through the kidney. So it's going to lower the filtration rate of the kidney, lower kidney function, in other words. Well, so you could say that it would lower blood pressure, but that's really not what happens, because what the kidney will do is then turn around and activate the renin-angiotensin system, and we already know what happens there is that's going to have lots of different ways of raising blood volume and blood pressure. So ultimately, it's going to end up raising blood pressure and blood volume.